For example 1, we want to solve the following equations. There's two separate ones. The square root of x minus 3 is 0, and the other one is the cube root of x plus 5 is equal to negative 1. So there's a technique that'll work for both of these. I'll start with the square root of x minus 3 is 0. The idea is get the root part by itself. I can do that really easily by adding 3 to both sides of this equation, no problem. And to get rid of the square root, I'm going to square both sides, because the square root of x squared is just x. 3 squared is 9. And it's pretty easy to see that this is the solution. You probably could have guessed it without even doing this work. The square root of 9 minus 3 is 0. Is that true? And it is. So I know that this is my only solution. So you can use that same technique for this other equation, the cube root of x plus 5 is equal to negative 1. Here, the root is already solved for, so I can actually not square both sides, but cube both sides. Whatever the root is, you'll take that as your exponent. So if it was like the fourth root, I would raise both sides to the fourth power, and so on. So the cube root of x plus 5 cubed is just x plus 5. The other side, negative 1 cubed, is negative 1. So by subtracting 5 from both sides, I get my solution of negative 6. And it's easy to plug this in and see that it in fact works. So with these two basic examples, this is the strategy that we're going to use to solve any equation that has some type of root in it. There is one other thing to look out for. So I'm going to come up with a brand new equation. The square root of x, I'll do plus 3 is equal to 0. So basically the very first equation, but I'm just changing the minus to a plus. I can already tell there's no solution to this equation. This is always positive. And if I add something to something that's positive, I'll never get 0. But just to see what goes wrong, I'm going to use the same strategy where I'm going to subtract 3 from both sides. That's not what I meant. Get rid of that. Okay, so I'm going to subtract 3 from both sides. And, okay, now I'm going to square both sides. And I still get x, and if I square the negative, it becomes positive 9. And it kind of looks like there is a solution. This method gave us x is equal to 9. I know, though, if we plug this back in to the original equation that, well, here it's 3 plus 3, is that 0? 6 equals 0, that's false. So basically, the strategy that we use to solve these equations, they'll give us solutions, but sometimes they'll give us things that are extraneous solutions. They just don't work in the original equation. So our way around this will be to just check to see if our answer works or doesn't. The first two did, but this last one did not. All right, now that we have a strategy for solving equations that have roots in them, we'll look at a couple that are a little bit more complicated. So here we have the square root of x plus 5, but then plus 1, which is outside of the root, and that's equal to x. I'm going to use, like I said, the same strategy where I'm going to subtract 1 from both sides. I'm going to change this to the square root of x plus 5 is equal to x minus 1. This way, the root is still by itself, so I can now square both sides. So I'm going to square the left and square the right. The whole goal is to get rid of the root symbol, and this will take care of that. The left side is going to be x plus 5. Now if I square out the right side, I gotta be careful. I get x squared, I get minus 2x and plus 1. So don't forget that when you square x minus 1, you're going to have 3 terms. So I've changed my equation from something with a root to a quadratic equation, and we have a lot of strategies for solving these. I'm going to subtract x and 5 from both sides and set this equal to 0. So 0 is equal to x squared minus 3x minus 4. And let's see. if I want to solve this equation, I think I'm going to factor it. I think this will factor, so I don't have to use any type of formula. This can break up into two pieces. Let's see, we get x and x, minus 4 and positive 1. And written this way, I can see that my two solutions would have to be positive 4 or I guess, negative 1. There you go, the solutions. But like I said, I want to check to see if they both work in the original expression. So I guess I'll start with 4. Why not? I'm going to plug that back into the original equation. So that is, we have the square root of, it'll be 4 plus 5 plus 1. Is that equal to 4? So putting 4 in place of every x. So we get the square root of 9 plus 1. Is that 4? And it is. 3 plus 1 is in fact 4. So that works. 4, that's good. That's a solution. What about negative 1? Okay, let's see. That's the square root of negative 1 plus 5 plus 1 equals negative 1. This doesn't look very good. Let's see. We get the square root of 4 plus 1. Yeah, this is not going to work. The square root of 4 is 2. 2 plus 1 is 3. It's not negative 1. So, nope. This is not a solution. So it was good that we actually checked both. 4 worked, negative 1 did not. So 4 is the only solution to our original equation. And for the last example, same idea. I want to find all numbers that work in this original equation. And my goal is to try to cancel every single square root. And this time there's 2 of them. I guess I could start by squaring both sides, but there's a better strategy. What I'm going to do first is I'm going to add the square root of x plus 1 to both sides. I'm going to change this equation to the square root of 2x plus 3 is equal to the square root of x plus 1 plus 1. I'm doing this because if I now square the left, it'll cancel the square root. I think the right side is going to be kind of complicated, but at least I've canceled one of my square roots. So that was step 1. Just move the one square root to the other side. I'm now going to square both sides, and I want to be careful here. The left side, easy. I'm left with 2x plus 3. The right side, I have to be a little bit careful, so maybe I'll make a note off to the side that when I square the square root of x plus 1, I'm going to get 4 pieces when I distribute the square root of x plus 1. I'm going to get first, let's see, the square root of x plus 1 times the square root of x plus 1. That's just x plus 1 because I'm squaring it. So I'll get x plus 1. But I also get the square root of x plus 1 because this gets multiplied to the 1. I'll now continue with this 1. So I get another square root of x plus 1. And then I get 1 times 1, which is 1. So I have plus the square root of x plus 1 plus 1. So that's what it looks like to square the right side. Got to be a little bit careful. There's going to be 4 terms. 2 of them are like terms, so I can start simplifying this. Let's see. I have x. There are 2 1s, so I get a 2. And I also get 2 of the square root of x plus 1s. I see I can like subtract a 2 and an x from both sides, so I think I'm going to do that. So by subtracting x and subtracting 2, I'm left with x plus 1 on the left and 2 times the square root of x plus 1 on the right. That was a whole lot of work, and all it did was cancel one of the square roots, and there's 1 remaining. But I can actually square both sides again, and the other square root will be canceled. So like here's the trick. If you see 2 square roots, you can still square both sides. We're just going to have to do it 2 times, 1 for each square root. So on the left and on the right, by squaring both sides, I have x plus 1 squared. That's x squared plus 2x plus 1. And on the right, so there's this extra 2 that's right here. But if I square that, I get 4. And if I square the square root of x plus 1, I get x plus 1. And there it is, squaring both sides, and all the square roots have been canceled. So I have x squared plus 2x plus 1 is equal to, I'll distribute the 4 and get 4x plus 4. Okay, I guess I'll subtract 4x and 4 from both sides. And I'm hoping this factors, and it does. I get x minus 3 and x plus 1. And that means my solutions are 3 and negative 1. Maybe they both work, maybe only one, or perhaps neither of them work, but this is what I'd like you to do. Actually take these numbers, plug them back into the original equation, and see if they in fact both work. They both should work, but you should definitely try that out. So again, here's our strategy for solving something with a square root, or any root for that matter. You basically just raise both sides to either a 2, 3, 4. It really just depends on the root that appears within the equation.